Hello, and welcome back to Harry Does Data. I'm Harry Norton, and this is my series on R programming for beginners. Today, we're going to take a look at objects. So we're going to look at what an object is and how you assign an object. Then, we're going to start looking at data types, which are also known as object modes. We'll start with numeric data types for now, and then move on to characters and logicals in future videos. Objects and data types are fundamental aspects of a lot of programming languages, and will form the building blocks of our R skills. So, let's get into it. But just before we do, don't forget to give that like button a quick tap and subscribe to my channel so that you don't miss out on more great data science content. Right, let's get going. So all of the code that I use for these tutorials will be on my GitHub. I'll put the link to it in the description of this video. But if you go to that link, you should get to this repository section and you'll see an R for Beginners folder. And within that are all of the tutorial files for this series. Well, at the moment, obviously it's only tutorial 2, but I'll put them in there as I go. So you'll see there's two different types of file here. There's just the standard tutorial 2 file, and that has all the code that I've done during this session within it. And then I'll also upload a tutorial 2 headings only file, which will just have the headings, none of the code. So if you want to code along, then that's the best one to download. If you want to just sort of watch as I do this and have the code there already done, then this tutorial 2 standard one would be the best one to download. So to download them, you can just go to code over here and download as a zip, and then extract those files onto your computer, or you can simply click on the file itself and then just copy and paste this into your own R script. So once you've downloaded it and opened up the script, it should look something like this. And this is the headings only version, obviously. And so now we should be ready to get going. I just wanted to jump in here and mention that I originally filmed tutorials 2 and 3 with the intention of them being one big tutorial. So the formatting of the code I show in the next 2 videos may not exactly line up with the tutorial files on GitHub, but rest assured the content will be exactly the same. So just a couple of quick notes before I get into the main bulk of this. When you write an R script, you can use something called comments. So anything with a hash symbol before it will be a comment, and what that means is that it won't be, it will be ignored by the R interpreter. So out of all this code that gets sent to the R interpreter, it will not do anything with the line starting with a hash. And also you can have a line of code with a hash statement sort of after the line of code, and everything before the hash will still be run, but everything afterwards won't be. Something else you can do with comments is folding your scripts. So if you ever put at least 5 hashes in a row, then that will give your script like a folding line. And all that means is, you see these little arrows here, because I've got 5 hashes in a row on this line of code, it allows me to fold my code at this point. So I can just fold all those up, and that will make my code look a lot neater. And you can easily see now what we're going to go through today. So as I've already sort of mentioned, we're going to take a quick look at comments, and then we're going to go through the main bulk, which is objects and data types. And now when we're working in a sort of individual section, we can just open up this individual section and it will look a lot nicer and a lot cleaner. If you want to fold or unfold all of your comments at once, you can use Alt and O. That will fold them all, and then to unfold them all, it's Alt Shift O. And as you can see, that is now all my comments unfolded. So I'm just going to fold them all back up again. Check that we got nothing else in comments to talk about. Okay, so I'm going to go through running scripts as well quickly. If you want to run the current line that your cursor is on, then you just press Control and Enter. And as you can see, that will return hello. If you want to run a section of script, then you can highlight that section and again press Control Enter, and that will run. And if you want to run the entire script, then you press Control Alt Run, but be careful here. You need to make sure that all of your foldings are unfolded before you run the entire script, otherwise you'll enter a debugging mode. So if we unfold everything, Alt Shift and O, and then press Control Alt Run, then that should run the entire script. Now, obviously there's not a lot to run in this script at the moment, but when you have a whole process that you want to run, that's how you would run your script. Right, so let's just fold everything back up again, Alt O. and we can move on to objects. So getting into the main bulk of it. So what is an object? An object is essentially a place to store a piece of information, a piece of data, or the result of another operation so that you can access it again later without having to run like your entire script again. So it's basically just a way of saving a piece of data. So if you want to assign an object, it's quite simple. So we could assign the object A using the less than followed by a hyphen symbol. And we can assign that the value 36 and then press Control and Enter to run that. And as you will see over here in the global environment section, the object A has been assigned the value 36, and the object A has a numeric data type, which we'll come on to again later when we talk about data types. You can also assign objects using the equal symbol. So we could assign the object B the value 3, and again press Control Enter. And you'll see again, that's just done exactly the same thing. It's assign the object B the value 3. The reason that we use this funny less than or hyphen symbol sign that looks a bit like an arrow will become apparent when we talk about overwriting an object now. So we can overwrite the object A by simply reassigning it a new value. And as you'll see over here, the value of A has changed. And something else you might do when you overwrite an object is use the previous object to inform how you're overwriting the object. So what I mean by that is we might want A to now be assigned the value of A plus 4. And you can see that if you were using an equal sign here, that might be confusing or just wrong, because obviously mathematically saying that A is equal to A plus 4 is just wrong. So we can easily use these objects that we've now created. We could do something like A divided by B. And we can see the value of A at the moment is 54 because we assigned it 50 and then added 4. And so 54 divided by 3, as you can see, returns 18. And we can also assign the result of that operation that we've done to a new value, to a new object. So assign A divided by B to the object Z. And you'll see that Z is assigned the value 18. So there's a few rules that you have to obey when you're naming objects. So let's have an object called object1 and assign it the value 3. And this is okay, because essentially an object has to start with a letter, and it can include underscores, numbers, and other characters after that letter, as long as it's begun with a letter. But you'll see that if you try to assign an object beginning with a underscore, so object underscore 1, don't know why I commented that, and then run that, you'll get an error. So unexpected input in underscore, all that means is the interpreter doesn't know what to do with something beginning with an underscore. Similarly, you can't start with a number. So if we try to start with one object, you'll actually see that it's a different color over here. So the 1 is highlighted a different color to the rest of the text. That's another one of the advantages of using the RStudio IDE that I didn't mention last time. So it will highlight different types of text and object in different colors, and that just generally makes coding a bit easier. If you're using a plain text editor, that wouldn't be the case. And so if I try and run that, you'll see again, unexpected symbol in one object. The error messages can be a bit vague, but just know here that you can't start a object name with a number or an underscore or anything other than a letter. So I'm just going to get rid of them so that they don't mess up our script anywhere if we try to run the whole thing. And move on to deleting an object. To delete an object, we have to use a function. So we use the rm function, and we can delete object1. So putting the object you want to delete inside these brackets and then running that will, as you see, has deleted object1 from our global environment. And talking of environments, this is essentially where everything in your current R session is stored. So there's quite a complex system of environments, probably beyond the scope of this course. But all we need to know is that everything we are using at the moment is stored in the global environment, and we can see that up here. If you're not using RStudio, and so you won't have this global environment shown up here, you can use the command ls to show all of the objects in your current global environment in the console. So that's our quick tour of objects. So I'm just going to close this objects section down, and we can move on to data types, which, as I've said previously, are also known as object modes. So what data type something is simply defines the type of operations that you can perform on it, and also how certain functions deal with the object. There are three types of data type that we're going to look at today, and they are numerical, character, and logical. So pretty much everything we've been dealing with up to now has been a numeric data type. I think I showed you some of the basic operations that you could perform on numeric data types last time using our objects from earlier. We could do a plus b, we could do a minus b, we could do a multiplied by b using the star symbol there. We could do a divided by b using a forward slash, and we could do a to the power of b using the little hat symbol. Now, if you have a more complicated operation that you want to perform that involves several of these operations, then I will follow the BODMAS order of operation. And so what that means is it will do things in brackets first, then it will do orders, so powers and roots, then it will perform a division, then multiplication, then addition, then subtraction. And just to illustrate that, I've got one of each in this line of code here. And essentially, I'm just going through line by line, doing the thing that R will do first. So first, it will perform the thing that is in brackets. So it will do 1 plus 2 and give you 3. Then it will perform the order. So there is a power over here. So it will do 2 to the power of 2, which will give you the 4 here. Then it will do the division. So 15 divided by 5 will give you 3. Then it will do the multiplication. So 3 times 10 will give you this 30. Then the addition, so 30 plus 3 will be 33. And then finally the subtraction will give you 29. So if we just run this first line, there we go, comes out as 29. So that's the order that R will do operations in. So in terms of numeric data, there's a few functions that you'll use a lot to do things to your numeric data. It's probably worth talking about functions and just talking about them a little bit more generally. A function is essentially a piece of code that someone has already written. So some of them come with the base R package, or some come in new packages that you can download and install for R. And what you do is you call this function and you give it a piece of data or an argument, and it will return to you something else. So a very simple example of this is the square root function. And we could call the square root function on square root of x equals 36. And you'll see that it returns 6. So if you want to know a bit more about a function, then you can simply type question mark and then the name of the function and run that. And you'll see that over here in this help section, it will tell you all about that function. So you can see that the square root function computes the principal square root of x, where x is the only argument, so the only piece of data that you need to pass to the function. And all it means by principal here is that it will give you the first square root. So obviously 36 has 2 square roots, 6 and -6, so it will just give you the first square root of that. Worth noting that you can also do square roots in a slightly different way, and it's actually all that this function is doing. As you see down here, square root of z equals z to the power of 0.5. So if you know your maths, if you want the square root, that's equal to putting something to the power of a half. If you want the cube root, then that's equal to putting something to the power of a third. So we could do 25 to the power of 0.5, and that would give us the square root, which is 5. Another function that is of interest for numeric data types is the logarithm function. So let's take a look at the logarithm function by doing question mark followed by log. And you'll see in the description of the function here that the log function computes logarithms. And by default, this is the natural logarithm. So what that means is if you don't apply a base value for the function, then it will simply use the natural logarithm. And another thing to note, when you start typing a function, it should give you a little sort of hint as to what the function is looking for. So it's looking for x, a value to do the logarithm of. and it's also looking for a base value. So let's give the function x equals 216 and base 6. So base equals 6. And you'll see that that comes out to be 3. And as I previously mentioned, if you don't provide it with a base value, then, so let's just do log of 400, then it will give you the natural logarithm. And that will essentially just give you the log to the base e, where e is Euler's number and is equal to 2.7182. So I can prove this by doing log of 400. We'll give it x equals 400 to the base equals 2.7182. I don't know that off by heart, I have it written down. And you'll see that that comes out with the same value, 5.991645 as the original log 400 call. One more function that's very related to that last one is the exponential function. So we could do exponential of x equals 7, and that is essentially e to the 7, 2.7182 to the 7, and that should come out with the same value. You can just see there's a slight rounding difference there because, and that's because R will have the value of E stored to a much greater number of decimal places than just these 4. We can use something called scientific notation to represent very big or very small numbers. So if we put, say, 25 million in here and just run that, you'll see that R represents it using scientific notation. And all this means is 2.5 times 10 to the power of 7, or 2.5 times 10 7 times. And we can also write like this in our script. So we could ourselves write 2.5 e to the 7, and that would again come out as 2.5 e to the 7 down here. You can do the same thing with really small numbers. So 0.0000025 is 2.5 to the minus 7. And again, we can write that up here in the same way. So 2.5 e to the negative 7, and it will come out the same. So that's it for this tutorial. Next time, we'll continue looking at data types. Specifically, we'll look at characters and logicals. Character data types help us deal with text-based data, and logicals are important for evaluating conditions and getting code to perform in different ways based on those conditions. Don't forget to like and subscribe so you don't miss out on the next video. Thanks for watching, and see you next time.